Let's discuss number 10. Question number 10 is about radioactivity. 10A. A technician sets up a radiation detector in a university laboratory for use in a class experiment. AI. A radioactive source that emits beta particles is placed on the laboratory bench 10 cm from the detector. A small count rate is registered. AI1. State the name of the particle found in an atom that is identical to a beta particle. Beta particle carries negative charge, so it is identical to electron. AI2. The technician sets up the same equipment in the same way every year. He notices that the count rate registered by the detector every year is slightly smaller than it was the previous year. Suggest why this is so. Some of the radioactive sources have already decayed, so the activity of the radioactive source decreases every year. Those are the answers for question 10AI. Question 10A II. In a second experiment, the same equipment is set up, but a radioactive source that emits alpha particles is placed 10 cm from the detector. The same number of particles are emitted every second from the source as were emitted from the beta source in I. Explain why the count rate obtained is much lower. The emission range of alpha particles is less than 10 cm. The alpha particles also has larger mass, which causes more collisions than the beta particles. We move on to question 10B. In another experiment, beta particles pass between two parallel horizontal metal plates in a vacuum. They then continue to the detector as shown in figure 10.1. A very high PD is connected between the plates with the lower plate positive. On figure 10.1, sketch the new path of the beta particles. Remember, beta particles carry negative charges. Negative charges will be attracted to the positive plate. In this case, the positive plate is the lower plate, so the beta particle will be deflected downwards like this.